What we're going to do in this video is we're going to try and understand the vertex form of a quadratic. Um, we're going to start with looking at the vertex form and getting information from it. Then we're going to get some information, starting with some information. We're going to see if we can write that information in vertex form. And then we're going to answer all those questions that we had given a quadratic that's in vertex form. Okay. All right, so vertex form of a quadratic function looks like this. So f of x is equal to, and this is our vertex form. It always has these parentheses with an x inside, and then a square, and then it's of the form x minus h plus k, and then it has the a. Remember that a that we had? That determines whether it opens up or down. That's on the front of it, okay? And in this case, here's what we're going to say. We're going to say where HK is the vertex of the quadratic, okay? So we can see the vertex right there in vertex form, which is very convenient. It helps us answer a lot of questions very easily. And so what I want to do here is here's an example of vertex form. So this is a quadratic. See, it's x squared, okay? And what I want to do is I want to show you how we can take this information, identify the vertex, and identify the a. And they're right there. Here's a, -2. And then we have the coordinates for the vertex, this number and this number right here, okay? But it's important that you understand that notice that the k is being plussed and the h is being minused, okay? And therefore, if we have a minus in the vertex form, then the x-coordinate is going to be positive. It's going to be +5. But if we have a plus, then that means that this number right here, this 2, is actually negative, because it would have to be x. Here, let me write this in. It would have to be x minus -2 in order to become x plus 2, okay? And so anytime you have an x plus on the inside, the h is going to be negative. Anytime you have an x minus on the inside, the h is going to be positive. But on the outside, it's what you see is what you get. If you have a +8, then the k is positive. If you have a -7, then that means that the k is going to be negative. It's going to be -7, okay? And so let's go ahead and identify. Here's what we're going to do with this information is we're going to identify the vertex, and we're going to identify a. And so in this case, so a here is -2. Very simple. A is -2, and therefore, well, we're going to get to what that means, okay? And then the vertex is at the point, let's see here. So we have this, it says -5, and minus is what we're supposed to have. See, in the thing, it says minus, okay? And so the vertex is at 5, comma, and then we have +8 here, so it's 5, 8. The vertex is at 5, 8. On this one right here, okay, a is equal to 1. Now you may say there's no number here in the front, but remember, when there's nothing there, if there's nothing being multiplied there, then it's a 1. Okay, so a is 1. And then the vertex is at, so this says +2, so that's minus -2, and therefore the vertex is at -2, and the k is -7, therefore it's at -7. Okay, so the vertex is -2, -7. Here, this third one right here, okay, you can see there's a negative in front of it, and that negative means that there's a -1 there. And so a is -1, and the vertex is at, let's see, we have x plus 4 here, and so that means it's -4. It's the opposite, okay, -4. And we have a +5 here, and that's always what you see is what you get. That's a +5, so we're going to put a +5. Okay, vertex is at -4 and 5. On this last one here, right here, you can see that a is equal to 3. and the vertex is at, we have x minus 6, and so it's always the opposite of what you see, so that's positive 6. So the vertex is at 6, and then we have a minus 1 here, and for the k, it's whatever number you see, which is -1, and there we go. The vertex is at 6, negative. Okay, now what we're going to do is we're going to write the function, the vertex form of the function, given the vertex and the a. So now we're going backwards. We're starting with the a and the vertex, and we're going to write the function in vertex form. So if I know that the vertex is at 4, 11, and that a is equal to 1, I know that I'm going to do that my vertex form of my quadratic is going to be f of x is equal to, okay, a comes first, okay, which is 1, but I'm not going to write the 1 because it's just, anything times 1 is itself, so we don't write the 1. So it's going to be f of x is equal to parenthesis x minus, well, the h is 4, so it's going to be x minus 4, and then squared, and then plus whatever k is, and k in this case is 11. And so it's going to be f of x equals x minus 4 quantity squared plus 11. Now let's move on to the second one here. A is equal to 6. So we're going to start off with f of x is equal to 6 parenthesis x minus, and then h is -3. So it's x minus -3. Okay, but we're not going to write it as x minus -3. Don't write it like this. Don't write x minus -3. Okay, what we're actually going to do is we're going to write it as, x, minus -3 means plus 3. So we're actually going to write it as x plus 3. Okay, plus 3, and then squared. And then we can see that that k is -5. So instead of writing plus -5, we're just going to write minus 5. Okay, so there's our second one. This third one here, f of x is equal to, a is -1. We're not going to write -1. We're just going to put a negative symbol, negative, and then a parenthesis, x. And then our h is 2, so we're going to write minus 2 squared. And then our k is -15, so we're going to write minus 15. Okay. And then the last one here, f of x equals, and our a is -7, so we're going to put a -7, parenthesis, x, minus, and then our h is -1. So it's x minus -1, but we're not going to do minus -1. We're going to do plus 1. Minus -1 is the same thing as plus 1. So we're just going to write x plus 1 squared. And then our k is +8, so we're going to put plus 8. Okay? And these are 4 examples of how if you know the vertex and you know a, you can just write the quadratic in vertex form. Okay, the last thing we're going to do here is we're going to take a quadratic function in vertex form. We have 2 of them here, 2 examples. We'll do them separately. And what we're going to do is we're going to answer all these questions that we had answered before. The only problem is this, is I want you to know that we cannot answer what are the x-intercepts, and we cannot answer what is the y-intercept, at least not just by looking at it. We can do that later by using algebra, okay? But we're not going to do those right now. I just want to answer questions that we can answer just by looking at the vertex form, okay? So first question is, what is the vertex? Well, we know that the vertex is based on h here and k here. And we know that h is the opposite of this x plus 7. It's going to be the opposite of plus 7. So the vertex is going to be at -7, okay? And then the k is whatever you see, which is -4. So it's -7, -4 is the vertex, okay? The next question we're going to ask is, what is the axis of symmetry? Well, we already learned that I'm going to abbreviated as AOS, axis of symmetry. We've already learned that the axis of symmetry is the line x equals whatever h is, which is -7. So the axis of symmetry, this right here, this number, -7, that's the axis of symmetry. X equals that number, -7, okay? Does this open up or down? Well, let's look at A here. We can see that A, we're going to jot this down on the side, that A is equal to -2, and it's negative. And we know that when A is negative, that it opens downward, okay? This one opens down, okay? Because A is equal to -2, okay? And then it says, what is the minimum or maximum? Well, we already learned that when A is negative, that there's a maximum. So this one has a maximum. And it's a y value. Maximum is y equals, and it's whatever k is. K is -4. Look. This is the maximum. K, the number that is in the vertex, is going to be your maximum when it has a maximum, okay? When it opens down, okay? So y is -4. Almost done. What is the range? And we already learned that when you have a maximum, the range is going to start at -infinity, and it's going to go up to whatever the maximum is, which is -4, and then we put a bracket, and we're done. Okay. Now we're going to do the same thing over here, only this one is going to have a minimum. This one's going to have a minimum because over here, A is equal to +1, and therefore this one opens up, and therefore it has a minimum, and therefore the range is going to start at whatever the minimum is, okay? All right, well, let's start with the vertex. And remember that the vertex is based on h and k, all right? So the vertex is it's the opposite of what you see here. So it's not -6, it's +6. And it's exactly what you see here, which is -13. So the vertex is at 6, -13. The axis of symmetry is going to be x equals 6. This one opens up. Okay, why? Because A is positive. A is +1, okay? This one has a minimum, because remember, when A is positive and it opens up, it has a minimum, okay? And the minimum, let's do this. The minimum is y equals whatever k is, which is -13. -13. And the range, when there's a minimum, starts at the minimum, which is -13, and it goes up to infinity, okay? And that's it. That's how we answer these questions if we're given the vertex form of a quadratic.